So higher degree polys, day 2. Basically, what is a higher degree polynomial? They have curves in them, lots of curves, kind of like this. And in fact, if it's like x to the 4th or x to the 5th, they'll have tons of curves. But how they interact with the x-axis is what it's all about. See how that one bounces right here? That's called a bounce. This one just goes right through at its root. It's called a cut through. This one is called a straight. I guess I don't call it a straight. I call it a cut through. That's what we call it in pre-calc. And a snake is what we call it in pre-calc. This kind is called a snake. And it's how it interacts. So the point is, if you have a graph and it does this, you can say, oh, I know that that is a x squared kind. That is a double root. It's a bounce. The bouncy things are worth 2. So in your equation, if this is, for instance, at 3, your equation must have this in it when it's factored. Okay, now just think about that for a second. Do you get that that is a parabola? It's been shifted right 3? All right. So then what if it was like this? It's got a bounce here and then a cut through there. Let's say this is at -2, and let's say that's at 5. Then the equation for this guy, it's got a cut through here. That's only worth 1, not 2. It's got a bounce there. That's worth 2. So I'd have 2 parts to my equation. X plus 2, because remember, -2 has to go in there and make it equal 0. And that one's bouncing, so it's a squared. And this cut through at the 5, that's x minus 5. That way a positive 5 can go in there and make it equal 0. And that one's just a single. It's a cut through. That's a 1. That's the equation for this graph. Now there is one thing we're not talking about, and that's the stretch factor. Like how high this loop goes up, that depends on the stretch factor. And we always just assume for this course, we're just going to use a stretch factor of 1 until we tell you otherwise. In pre-calc, we get into figuring out what that stretch factor is. It's really not that hard. But we're going to assume a stretch factor of 1 for now. One more thing. This would be degree 3, which means the ends are going opposite directions. But something is wrong about my equation. Can anybody figure out what's wrong about my equation that doesn't match up? Yes, sir. Yeah, because it's doing what? Yep, because it's going down on the right side. There's got to be a negative somewhere. So all you got to do is throw a negative in front like that, and now it's right. That'd have been a really easy mistake to make. You got to check for that because people make that mistake all the time. All right, now let's go back onto the smartboard presentation here. Give an equation for the graph below in factored form. All right, so here's the 2 roots. You get that one of them's a snake? That's to the power of 3. The simplest of all of those was the x to the 3rd graph. It looks like this. And now, why is that type of cutting through special? Because it's increasing the entire time, but it changes at that moment from increasing at a decreasing rate. Remember doing this in the first few weeks of school? Increasing at a decreasing to increasing at an increasing rate. At that exact moment is its inflection point where it changes from, it's always increasing the whole time, but it changes from one kind of increasing to the other kind of increasing. That makes it special. That makes it x to the 3rd. All right, so this equation then is, it's going up on both sides. Do you agree that since they're both going up, that it's even? And do you get that on the right side it's going up, so the lead coefficient is positive? All right, so then since it's even or odd, leading coefficient positive or negative, we know that this has got to be positive something because it's going up on the right. And x to the what? I don't know. I'll figure it out by looking at these. How much total? Well, how much is this one worth? 3, and this one's worth what? And so then total of 4. So I know this thing has an x to the 4th in it. All right, I personally think it's easiest to just go write the equation. 2 sets of parentheses. I showed you how to write it 2 seconds ago. Write the equation for this one. If you can't do it yet, then you got a little learning left to do, because that's our main goal for today. Get you to be able to write equations based on looking at a graph. Say, oh, I can see from the roots. I know it's hard to read. That's at -3 right there. And that's at +4. Miss P, could you shut that door for us, please? Thank you. Okay, you should have said x plus 3 for that one. And this one was not one of those special bounces or triples, so it's just a single. So you could put a power of 1, but you didn't have to, because if you don't put a power of 1, it'll be a power of 1. All right, this is x and -4, because that way this +4 here can go in and make it equal 0. Then it's a 0. All right, and then this one's a snake, so I put a 3. And then what do I check for at the end, that thing that you caught before? Is it flipped or not? Yeah. And this one's going up on the right, and therefore it's positive in front. So I do not want to put a negative there. I leave it alone. No negative. All right. Raise your hand if you had that right. Awesome. I think I'm going to take you guys to the next level, because research has shown if you teach kids more than they need to know, then they understand the earlier stuff better. All right, so let me just show you just a little more, because this is kind of cool. Do you get that the one thing we don't know is the stretch factor? What's the stretch factor? Well, I don't know, so I put an A there. Now, how could I figure out the stretch factor? You have to take some point on here that is not these roots, okay? Because the roots, if you plug them in, they make the whole thing 0, right? But if you take any other point that's on here, so like for instance, let's say this point, it looks to me like the point 6, 1, 2, 3, 4, 6, 4 is on this graph. By knowing 6, 4 is on the graph, don't I know an x and a y that have to work? Get that? That's what 6, 4 means, is that if I stick in a 6 here and here, the answer has to be 4. Get what I'm saying? So then I now have an equation. 4 equals a times 6 plus 3 times 6 minus 4 cubed. And isn't this just a great big equation that only has one letter in it? A. And then I can solve it for a. And now I know what the stretch factor is. Okay? So all I had to do to find the stretch factor was stick in some other point. Can't be the roots, because they'd make the whole thing 0. Okay? In my ideal world, we would add this to the course, and we might next year, but for a while, I just wanted to show you, because it's not that big of an add-on. For right now, we'll just always tell you that the A is 1, but we're kind of cheating because we don't really know what the stretch factor is, and we could figure it out with that method I just showed you. Yes? How would you factor out a cube? Well, you are not going to be expected to take something like this and factor it. Not yet, anyway. We are going to teach you that, but you aren't expected to be able to factor that yet, so don't worry. We will be giving them to you in factored form. Okay? So if I tell you this, what I want you to know is that and that tell you everything, right? This tells you, okay, first of all, everybody, before I assume too much, give me a quick sketch that could be right from that graph, or from that equation, sorry. Give me a quick sketch and turn it my way, and I'll tell you if your sketch could possibly work. Yep. 5 people, 6 people, 7. Nope, your y-intercept's messed. 7 people, 8 people, 9 people, 10 people. Make sure it's your y-intercept that you're looking at. 11 people right, 12 people right, 13, although yours has got this loop at the end, which would mean it wouldn't pass the vertical line test. Okay, so you can't get too crazy with your loops. Good, 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 good. Your y-intercept is negative where it really should be positive. Yes. Yes. All right. Yep. Okay. So I can tell now that you all know that this one has to be going up on the right and down on the left and has to hit at 2. That's all you know from this kind. Now, if we give you ones that we were favored the factor, they would probably have to be quadratics realistically, or we'd have to like cheat it a little bit and like make it something like where we give you the thing that's already factored like this, and then we'd expect you to know how to graph that. Everybody sketch that quick. You know what the roots are. You know where it's bouncing. You know, it has to end going up or down based on the graph. Okay, make me a quick sketch that goes with that. I'll pause for a second and have you try that if you want it. Thank you. All right, so all of the things I circled and put arrows to right up here, those all tell me stuff about my graph. So I'm going to go through quick what yours should look like, and you judge for yourself if you did it right. Okay, that negative in front means your graph has to be going down on the right. Otherwise, you didn't do it right. It's really easy to mess that up. Okay, next. This x plus 2 means one of your roots is negative 2. Boom, has to be touching there. And in fact, it has to be cutting through right there. Next thing, this little one, that's the cut through sign. It's not a bounce. If that was a bounce, it'd be a 2. That's a cut through. So that means it's going through like that, or maybe the other way, but I don't know until I look a little further. The next thing is that tells me that negative 3 is another spot on my graph. It's going to touch right there. And that one is a 2, so it has to be bouncing there. It could be bouncing this way, or it could be bouncing that way. I don't know until I'm done. Last thing, together these make degree 3, so that means they have to be going opposite directions on each end. And since this one has to be going down because of the negative, this one has to be going up. And now I have to bounce here, so I'm going to go bounce, cut through, and then head down. And the one thing I don't know, just realized it when I crossed it, is what's the y-intercept? How do you get the y-intercept? That sentence I've been making you say over and over and over again, because the y-intercept is not on the screen. The y-intercept is where? Finish that sentence. X equals 0. So you stick in a 0 here, and you see what you get. Negative 2 times 3 squared is 9. That means negative 18. Did my y-intercept cross in a place that's possible then? Well, it depends on your scale. Should have probably gotten lower than that, but how about if I make it go like this, and that'll make that curve quite so weird. And if it just goes down like that, eventually it would touch at negative whatever. Again, I think it was negative 18. Okay. Did your graph, how many of you had a graph that would have met all the rules? Okay, only like 2 people. So let's try it again. Now let's get a little bit smarter. You watch me do it. I'll make this one negative again. X plus 5 squared, x minus 3 squared also. Make me a graph that would work for this. If you want to check it with me, I can tell you if you're doing it right or not. Don't feel bad if you're wrong, because this is a tough one. But you're right. Nice job. Yours is acting like it's an odd one, because it's going opposite directions. Do you agree that looks like it's more like an even one? Good. Yes, sir. Yep. Yep, that's it. Oh, I didn't even check my y-intercept. Just a second. Let me check my y-intercept. Your y-intercept's positive. That y-intercept is telling me it should be negative. So something's wrong with yours. Yep, that works. That works. That works. Nice job. Oh, wait a minute. One of yours it's everything's awesome except for one of your numbers is positive or it should be negative. Do you get how the two roots, one of them's positive, one of them's negative? So try to figure out which one of yours you put as a negative or it should really be a positive. Yes. Yes. Can you zoom in on it more? Still can't see it. Yes. That works. That works. That works. Yours looks like it's odd because it's going like this. Shouldn't be odd. Should be even. Good. All right, I know there's a few people that didn't answer because they weren't sure what to do. So let me show you. Here's the first step. I know because of that, it's going down on the right. If I were you, every single time, I would start with that. Okay? Because it's so easy to forget that. And if you don't notice it, you can have everything perfect and not even notice that it should have been ending going down. All right, then I got to have a -5 and a +3. -5, +3. Okay? And they got to bounce at both those spots. And since it's a total degree of 4, it has to be going down on both sides. Even ones have to be the same, and this one has to be going down over here, so it has to be going down over here. They have to be the same. And then the only way I can make that work is if I bounce again, and head down. And there we go. Now, how low does this go? Well, it is actually supposed to be like negative, let me think. 5 squared is 25, and 9 squared is 81. 81 times 25. So it should be way down there. Oh. Yep. Okay, hold on. So, okay, thank you. 5 squared is 25. 3 squared is 9. 9 times 25. Still a big number, but not as big as I said. And then it's -2. So negative some huge number. So this should probably really be way down there. Wow. Yes. How do you know if it's a bounce? Because of this squared right here. If it's squared, it's a bounce. All right, let's do one more. This is going to have 3 roots. Extra complicated. Throwing in another negative. X minus 2 squared. X minus, no, plus 5 to the third. X plus 2. There we go. Pause for a second. Let me try that one. Okay. This one was a challenge. A lot of people had it slightly wrong, and then I give them a tip, and then they'd fix it. All right. So this would be a tough one, but you should be able to do this by not tomorrow, but the next day. That's when our quiz is. Okay. So you have one day to review this. So this negative in front, right away, I would start with that. You should know it goes down at the end. You just get that right off the bat. It saves you a ton of time. Okay, next thing. That's a +2. Got to hit there, and not only that, it's got to bounce there. You might even want to make notes for yourself later, like it's going to bounce there. -5. Has to hit there because of this, and it has to snake there. I'm going to put a little S for snake. I'll go back and snake it later. And this is -2. Has to touch right there. Okay, now, let's see. Degree 2, 3, 4, 5, plus that one makes 6. Degree 6. That means both ends have to be going the same way. Has to end down and down. A lot of you that I checked, Yours was going up and down like this. You've got to double check that right away. This could not be right because this is saying odd, but this adds up to 6, which is even. Okay, so it has to be going the same way. Okay, and now I can just do the things I need. Snake through this spot. Let's see. How am I going to snake through there? You basically act like you're drawing x to the third graph. Okay? Then it's got to, let's see, what's it going to do at this -2? It's going to bounce there. Nope, I'm doing something wrong. I got to be doing something wrong. Oh, the -2 is this one. There we go. That's a cut through. Okay. Phew. And then, oh, I never even thought about where the y-intercept was. Just to double check it quick. Y-intercept is where x is 0. See why I can make you say that so many times? Just because that's one little piece of this big puzzle. All right, so then that's -2 squared, which is 4. This is 5 cubed, which is 125. And all you needed to know was big number. And this one is 2 times 1 is 2. And then I got to remember this negative all of that, which is actually -1,000. So it'd be really way down there. And then comes up, bounces off of this, and goes down. And there we go. That's what you should have had. Something like that. All right. Now I'm going to give you one more. And this time I'm hoping I get 80% of you can get it right. Remember, start at the beginning. All right, so let's try -x minus 9 squared, x plus 3 cubed. Oh, and I'm going to throw in just an x in the front. Let's see if you, I'll give you a tip on this one. This x that's in the front, just put a parenthesis around it and act like it's like any other root. It's just like any other root. Don't let it freak you out because it's just an x out there. Okay? Try that one. It's a little puzzle. Pausing while you try that one. Okay, so we're analyzing this one, and we've got this negative in front, meaning it's down on the right. It's degree 6, means it's down on the left also. It has to bounce here, and it has to snake there, and it has to cut through there. So now we just have to put those last pieces together. Bouncing, there's only one choice, it has to bounce. Now I'm guessing, oh, the y-intercept I didn't have to even figure out this time, because the y-intercept is at 0. Think about that for a second. If I wanted the y-intercept, I could put in x equals 0. As soon as I put in a 0 there, it's going to times by all of this stuff and turn it all into 0. So the y-intercept is 0. Okay, and then I have to snake through this last part. Okay, this snake part, I'd rather draw from this side. And then I'm going to come down and touch there, and there we go. Raise your hand if you had that one right. Oh, you just didn't have confidence in yourself. Almost everybody had it right. Okay. So if there was parts that you're not getting right, make sure you like go over it right now in your head and get it straight while you're understanding it. So, okay. Let's talk about a few other things that are on this smartboard. There's not too much left. Take a look at this one with me. Okay. This one's got, instead of taking an equation and making the graph, here's the graph. You tell me the equation. Now, you don't have to be that concerned with this y-intercept, because look, I can't even tell exactly where it is. It looks like it's maybe at about 7.5. There's no way you're going to be able to use that. But at least you know it's negative for the y-intercept. So you're writing me an equation, always have y equals, and always right away check if you should lead with a negative or not. So easy to forget that. Don't just launch right into your parentheses. Do you lead with a negative on this one? Yeah, because it's down on the right. It's too big. I'll tell you the answer in just a sec. I'll pause for a sec. Okay, so here's how you should have thought this through. That, I hope, looked like a snake to you. Do you agree? So it's a snake at the 5, and that means, sorry, it's a negative 5. So that means it's x plus 5, and then, because that's an opposite of the one that's in there. And then it's a snake there, so that's a 3. And then the next one is a cut through at the negative 3, x plus 3. Cut throughs just have a 1. I can put a 1, or I could just have left it, and it would have been fine. And then the last thing is it's a bounce at the positive 1, x minus 1, and the bounce makes it squared. Then if I really wanted to be extra careful, I could go through and make sure that when I looked at my answer that it had a negative y-intercept, okay? And this thing getting squared means that that's positive 1. This would be times positive 3, makes 3. And this will be 125. 125 times 3 is some really big number, but then it makes it negative. Okay, so actually, in the real world, this answer could be right, except there's probably a stretch factor. But you remember how I was telling you, we're not going to make you figure out a stretch factor for these? So there's probably some A that we don't know right there, some stretch factor, and it's actually probably a decimal, some really small decimal, because it should be going to some huge negative number, and it's only going to negative 7.5. So, okay. So there's, how many of you would have had that one right? Okay, awesome. That's a good way to end. I'm just going to make a quick look and make sure that there's nothing super important here. This is all review, and we're going to review tomorrow. So I guess the ones I would mainly want you to understand is increasing and decreasing. Remember how it's decreasing in this zone and increasing in this zone? So let's do some of your homework together on the increasing, decreasing part, and we'll call that good. There's a lot of terminology in here if you want to look through that. Very dense wording kind of stuff, but I'm not going to go over all of that with you because I wanted to work on the hardest problems with you, which I think we did, and I think you did pretty well by the end. So that's all I have other than the homework, so I'm going to try to find the homework here while I pause. Okay, so your worksheet looks frighteningly like yesterday. In fact, it is the exact same thing as yesterday. It's just that you've already done sections 1, 2, and 3, and now we're going to do sections 4, 5, and 6. Section 4 starts right here, and that's the increasing and decreasing, which I mostly taught you yesterday. So let's do one of those together right now. State the increasing and decreasing intervals. Oh, easy peasy. It's increasing in here. So how do I say that? It's increasing from, well, where does it start? Does it start at any distinct point like here? This is assumed to go forever. So that means it starts, remember, we're talking about x numbers here, right? It starts infinitely over there. And it keeps increasing all the way up until that moment. So this is from negative infinity until 0. It was increasing. And then decreasing from 0 to forever that way, which a lot of people say negative infinity because they follow it down here. These are x's. That's why I'm doing it up on the x-axis. It goes forever that way. Okay? Use parentheses for those. If you used brackets, I wouldn't mark it wrong, but because there are some books that actually do it with brackets. So it's not like it'd be wrong. It's just we usually use parentheses. Okay, would you agree that it is increasing this entire time? A lot of people divide that into 2 parts. You can, but you'd have to do it with a little union sign between them and say it's increasing from here to here, and then you'd say it's increasing from there to there, which would really be smartest to just say this one increases forever from negative infinity to positive infinity. So what do you do on the decreasing? It never is. Again, if you wanted to break it up into negative infinity to 0, and then union with 0 to infinity, but that's not as good because it's much more likely you're going to screw up something. So I would just have said negative infinity to positive infinity. All right. Now let me go through a little further with you. I think the increasing decreasing is something I don't want to skip any on because those are important and we didn't do much in class today. Writing equations for these should be, oh my gosh, easy compared to what we did. We were working on the hard ones, so that makes it really easy to go through and do your homework and practice the easy ones. So I guess there's even a few too many of these easy ones. Why don't you skip like C, B and C in that section. And then if I can look at this last section quick, there's only like one on the last one, so just skip B and C in that second to last section. And that's all I got for you. Tomorrow we'll review, next day we'll test. Have a good day. And